Comparing rational numbers. The target for this lesson is, I can order and compare rational numbers. Let's start with vocabulary. A rational number is a number that can be expressed as a fraction of two integers. Rational numbers include whole numbers, integers, and most fractions and decimals. The Venn diagram at the right shows that all whole numbers are integers and all integers are rational numbers. The set of rational numbers also includes negative and positive fractions and some decimals that are the result of the division of two integers. Example 1. We'll do this problem together. Find the value of each expression and graph each rational number on a number line. Begin by creating a number line with negatives on the left, 0 at the center, and positives to the right. I notice that the largest value in this set of problems is 3.5 units away from 0, so let's extend our number line from -5 to +5. Problem A. What is the absolute value of -3.5? The absolute value of a number is its distance from 0. -3.5 is 3.5 units away from 0, so the absolute value of -3.5 is 3.5. We will plot this as point A on the number line. Problem B. What is the opposite of -1/2? Notice that parentheses are used. These are not absolute value symbols. The negative in front of the parentheses is indicating the opposite of what is inside of the parentheses. The opposite of -1/2 is 1/2. We will plot this as point B on the number line. Problem C. What is the absolute value of -1.5? The absolute value of a number is its distance from 0. -1.5 is 1.5 units away from 0, so the absolute value of -1.5 is 1.5. We will plot this as point C on the number line. Problem D. What is the opposite of the absolute value of -3? Because the absolute value of a number is always positive, the opposite of the absolute value of a number is negative. The absolute value of -3 is 3, and the opposite of this is -3. We will plot this as point D on the number line. Extra example 1. You'll try this problem by yourself. A. What is the opposite of -2.8? B. What is the absolute value of 2/3? C. What is the opposite of the absolute value of -0.25? Pause the video and try these problems on your own. When finished, unpause the video to see if you were able to successfully solve the problems. The answer to problem A is 2.8. The answer to problem B is 2/3. The answer to problem C is -0.25. Example 2. We'll do this problem together. Use a number line to compare -7.4 and -7.38. -7.4 is the same as -7.40. Since we need to compare -7.40 and -7.38, let's create a number line that extends slightly past these numbers. We will start at -7.42, and let's go all the way to -7.38. Decimals on a number line get larger as you move from left to right. -7.4 is located at -7.40, and -7.38 is located to the right. So -7.38 is greater than -7.4. Extra example 2. You'll try this problem by yourself. Compare -5/6 and -3/4. Hit pause and attempt this example. Check your answer by resuming the video to see if you got the correct answer. The answer to this problem is -5/6 is less than -3/4. Example 3. We'll do this problem together. List the following fractions from least to greatest: -1/2, -1/6, and -1/3. To compare these fractions, we will need to find a common denominator. Let's start by finding the least common denominator of 2, 3, and 6. The multiples of 2 are 2, 4, 6, 8, 10, and so on. The multiples of 3 are 3, 6, 9, 12, 15, and so on. The multiples of 6 are 6, 12, 18, 24, 30, and so on. The smallest multiple these numbers have in common is 6, so the least common denominator will be 6. Now we will convert -1/2 and -1/3 into sixths. To convert halves, multiply the denominator and numerator by 3. 2 times 3 is 6, and 1 times 3 is 3. so negative 1/2 is equal to negative 3/6. Negative 1/6 does not need to be converted because it is already out of sixths. To convert thirds, multiply the denominator and the numerator by 2. 3 times 2 is 6, and 1 times 2 is 2. So negative 1/3 is equal to negative 2/6. Now we can compare these fractions by graphing them on a number line. Since all of these fractions are less than 1, we can create a number line that goes from negative 1 to positive 1 with 6 marked off on each side. Negative 1/2 is equal to negative 3/6, so that is located here on the number line. Negative 1/3 is equal to negative 2/6, so that is located here on the number line. And negative 1/6 is located here on the number line. Since fractions on a number line get larger as you move from left to right, the fractions are shown in order from left to right. From least to greatest, the fractions are negative 1/2, negative 1/3, and negative 1/6. Extra example 3. You'll try this problem by yourself. List the following decimals from least to greatest: negative 0.3, 0.6, negative 0.19, and negative 1. This would be a good time to pause the video. Complete the problem by yourself, then check your answer by resuming the video. The answer to this problem is negative 1, negative 0.3, negative 0.19, and 0.6. Consider this. Compare and contrast the processes of ordering rational fractions versus rational decimals. What similarities and differences do you notice?